In this video, we're going to review a very simple x86 assembly language program. This program illustrates some of the aspects of programming in assembly, specifically treatment of pointers. Consider the following simple program in C. This program swaps the location of two 64-bit integers in memory. The integers themselves aren't named in the program, but for convenience we'll call them x and y. What we actually have as formal parameters to our program are pointers to the locations of x and y in memory. These pointers are named xp and yp, respectively. We fetch x and y into local variables t0 and t1 by dereferencing their pointers. Then we store the integers back into memory, each in the location previously occupied by the other. That's how we do this swap in C. And if we compile this C program into x86 assembly, we might get the following x86 code, though the specific results would depend on the compiler and the level of optimization. We've added comments to show the relation to the original C program. First, recall that by convention, the parameters to any routine are passed in order in a specific list of registers. The first parameter, xp, is passed in register RDI, and the second parameter, yp, is passed in register RSI. For this program, we also use two other registers, RDX and RAX, to hold the intermediate results. These correspond to the local variables t0 and t1 in our C program. In any assembly program, it's a good idea to record how you're using each register. In this case, we might do this in a table as follows. We'll add the values later. Now let's illustrate the execution of this program with concrete data. Suppose that integer x has value 123 and integer y has value 456. Suppose also that x is stored in memory at location 120 and y at location 100. Hence, the relevant region of memory looks something like this. Recall that xp is in register RDI and yp is in register RSI. What that means is that RDI and RSI contain the addresses 120 and 100, respectively. Registers RAX and RDX also contain some values, but we don't know or care what those values are at this point. So at the start of execution, we have the following state. And we're ready to start executing our program. The first line dereferences the pointer xp and puts the result into t0. Or, at the level of the assembly, we take the value pointed to by RDI and put it into the temporary register RAX. Since the address in RDI is 120, that means to get the 8-byte quantity 123, starting at address 120, and copy it into RAX. Line 2 implements a similar operation for yp. That is, we move the contents of the address pointed to by RSI into register RDX. That is, copy the contents of memory location 100 into RDX. At this point, we've saved the two integer values we want to swap in temporaries. Now it's time to write them back into memory. In line 3, we put the integer y, i.e. 456, which we previously stowed in temp t1, into the address pointed to by xp. In C, we do this by dereferencing pointer xp on the right-hand side of the assignment. In assembly, it's simply a register-to-memory move. Finally, on line 4, we put the integer x, i.e. 123, which we previously stowed in temp t0, into the address pointed to by yp. This gives us our final state. At this point, we've accomplished our goal of swapping the values x and y in memory. This program is very simple, but it illustrates a couple of points. First, it illustrates the treatment of C pointers in assembly. The x86 addressing modes make it quite simple to dereference a pointer both on the left-hand side and the right-hand side of an assignment. Second, this program illustrates that often there's a very direct translation from C into assembly. This would not be the case for some other high-level languages such as Java.